All right, let's get started on this Monday. So this is week one of Unit 6. So if you remember, this is nice because we don't have anything due this week here. We will want to move a little faster this week. Maybe you might want to do a little bit ahead of time because next week, right, is Thanksgiving there. Is it next week Thanksgiving? I think it is.
Yep.
Right, and so it'll be a short week. We'll want to get through as much material as we can this week and next week so that you don't have to do anything over Thanksgiving break, hopefully. So normal unit, and again, hopefully by now these units are beginning to seem kind of like, oh yeah, this is what we do in this class, sort of standard pattern. So there's the reflections. So click on the Unit 6 reflections, start working, make your copy of that, start working on them as we go through these classes. You're probably getting to the point now where you realize like I don't necessarily have to do everything we do in class as long as I do all the reflections there. So, that is just fine. We're trying to learn stuff, but the important thing is that you do the reflections. So anything that's required for your reflections, you should be watching and paying particular attention to that sort of stuff going through. So again, we're just going to go. This unit's on networking and connections and that sort of stuff. So we'll deal more. And we're also then going to be looking at how do we keep things secure on the internet, and we'll do some cryptography, secret coding sort of stuff as part of this activity this week. So let's just jump in. So again, in Unit 6 here, we'll start today doing not any coding, just talking about IP network architecture, that sort of stuff. Wednesday, we'll do probably the Caesar Cipher app and start working on that there. And we'll try to get through that. I may try to get through a little bit more than what's in part 2 this week so that next week we don't have as much stuff due. We'll see how far we go here. But we're going to start with 6.2, computer networking here. So we're going to learn about, again, we talked about this earlier, I think a little bit, what's the World Wide Web and some of these protocols out here. Today we're really going to dive into what's the structure, the layers of network protocols that run the internet here and run most of our networking stuff, and how do we organize it and why do we organize it in layers, and how do we send communications on noisy, unpredictable lines and still guarantee that the information will get through to the other end here for things. So we'll do a little activity on that. I'm going to bring up this slides here, and they walk them through in a couple videos, but I'll just kind of walk through this sort of stuff. And again, there are different structures to the network here in different ways. And we often mix these different networks or protocols together in different ways here. Sometimes we'll have a central broadcast kind of point that'll send and maybe connected to lots of other things. So Wi-Fi works that way. So like here, this is the Wi-Fi router. I can get it out, right? Yeah, well, maybe if it's all, but this is just the Wi-Fi router. And so it will send out signals, and then your phone, your tablet, your TV, your, computer might all be connected to this with Wi-Fi. So again, this would be at the central location here, and we have all these things connecting to it there. Now, there's other protocols like this Ethernet protocol here, where we actually put things all kind of in a row, string them together, and work on that. But in reality, while we often have this kind of stuff, we actually are going to mix these together. So while this is a hub and lots of things will connect it, and again, not just Wi-Fi, but there are 4 spots to connect dedicated machines to this. But this has to be connected to our main network. So there's a special yellow plug-in here to connect this to our internet service provider or wherever we're getting internet. So again, we might have this, but then there'll be another connection where this is connected out to the internet in some ways. So, and this is what kind of forms our, what we often, well, we used to call local area network here. And again, we'll think of like St. Scholastica also as a local area network here. It's kind of an ambiguous term right now, is where, you know, do you think of all of St. Scholastica as one local area network, or do you think of like each dorm as, or each, you know, hallway, or each building as its own local area network there? So, and again, we're running Ethernet on campus here, so you'll see Ethernet cables. So Ethernet is, I was going to say, it looks like your phone cables, but I bet you've never actually seen a wired phone. Back in the olden days, we used to have phones with cables that would plug into the back of the phones and do things. And so this is like this. This is actually a bigger plug than old phones used to use, but this is like this little plug-in. And so we use this sort of cable. It might be in different colors, others doesn't really matter, but it's this kind of cable. It has these little clips here that you clip in and you connect them together. And this is often called Ethernet cable or Category 5 cable or twisted pair here. Now, why is it called twisted pair here? I'm going to hand around some of this stuff. So have you seen twisted pair wire? So I'm going to hand around some of this. Let's pass it around.
Oh.
And how many wires are there in twisted pair wires? You have to pass right this. Sorry. You can't hog the one demo, or the 4 demos I have. So there's only 4. Yeah, only 4. So twisted pair wires have generally 8 wires in them, and they're kind of twisted together in pairs, and that's why we call it twisted pair wire there. And that's what makes up most of the internet. In fact, if you look around the room here, that is what you're going to see. So if you look at what's coming out of these computers here, there'll be an Ethernet cable, and you'll see it coming over here. These are the plugs. This is this twisted pair that plugs into there. Each one of these computers, you'll find all of them are plugged in to some outlet, and then the outlets are running in these conduits. In fact, you can see them. See right there, and the blue wires right up there, runs over the ceiling, runs over here, and a lot of it runs in suspended ceilings up here. There'll be a connection that runs into a room over there where all of them are pulled together there. So that's our Ethernet wiring. But then to connect up the space on campus, we use high-speed wire, and you might actually have this coming into your house. This looks a lot like this, but this is different. This, if you open it up, has 8 copper wires. This will have generally a single optical wire. So this is fiber optic cable here. They'll have a different kind of connection just with a single end on it there. So this is fiber optic cable. So we run this when we need a really fast connection between buildings at St. Scholastica. We run this here. You might have fiber optic coming into your house. I don't think many places in the Duluth have fiber optic coming in your house. But if you live somewhere outside of Duluth, you might have fiber optic. Does anyone know if they have fiber optic going to their house where they grew up? So,
Is it in the country more?
it tends to be more in the bigger cities, but a lot of rural areas have spent a lot on infrastructure. So I don't have fiber here, but at my cabin in Grand Rapids, I have fiber to my cabin. So I have really fast internet at my cabin there. So again, there are areas of Minnesota that have fiber to the premise is what we often, or to the house there. So the other thing I can say is Wi-Fi, where we're connecting devices to our network wirelessly. So besides these cables, we can send things over the air. I think it's kind of confusing sometimes when we think about Wi-Fi and how that works, because there are actually a number of different wireless communication networks that we use. So think of all the things that you connect to wirelessly and how far there. So do you have earbuds, or what do you have that works on Bluetooth? Do you have earbuds? Yes, right? You have your earbuds, right? How far do your earbuds go there in, like if you were start here and you start walking down the hallway, and you left, let's say you leave your phone here and you start walking down with your earphones, how far will you get before they quit?
These are actually pretty impressive. I was surprised. On like a 400-meter running track.
Yeah.
I leave my phone.
Wow. But that's open. Yeah, and so that's one thing you'll see when it's open, we can go a lot farther there. So yeah, that's interesting. Outside, you can do it. In a building like this, how far can you go? Can you?
Do you want me to go test?
No, no. You've done this, right? You've left them, and have you gone to like another room? Certainly, when you run to the bathroom, they still work, right? Dorms.
And then go over to your friend's room, and like still works, but if you go down like 3 rooms,
Yes.
it won't work.
About 3, yes. Yeah, 1 room over generally works more than 3 rooms. And again, in a house, you got 1 room over, but again, so there's a distance where Bluetooth fades out here, there. Do you know anything that's shorter range than Bluetooth? That you communicate? There's anything where you have to be really close to it for it to communicate?
AirDrop
Yeah, like AirDrop. What is AirDrop?
or nearby share?
Yeah, or well, like how do you pay? When you go to the store and you buy something, you tap RFID or it kind of yeah, so or something like that. So tap, how close you have to be to tap? You have to be like, yeah, within at least, at most a couple inches. So there are some protocols that are very close here. And Bluetooth, Wi-Fi. So how far can you be? So again, with this, so we used to have one of these in my house, and we could get internet most places in our house with one of these Wi-Fi routers. But again, as you get kind of further away, especially if we're streaming, it doesn't stream so fast here. So now we run a mesh of 3 routers in my house so that we can get it. But again, Wi-Fi is again working for this middle range here, where again, there's a Wi-Fi here. There's probably one in the middle of the hallway of Tower. There's probably 4 on this floor of Wi-Fi. Is there 1 on each dorm floor? I would guess probably for this. So 1, and again, there's so many connection strength, and also how many connections we can get to it there. I was just flying this last week, and they say free Wi-Fi, and so I connected to free Wi-Fi. But I mean, I don't know, there's 100 people on the phone on the plane, and everyone's trying to use the free Wi-Fi, and there's probably only 50 connections available on that Wi-Fi. So after a while, it was, when I got around to doing it, it wouldn't allow any more connections there. So that's another thing to watch. So, okay, Wi-Fi. Well, here, I'm trying to remember what I was asking AI what these ranges. So Bluetooth is typically less than 10 meters, but outside can be 100 meters or more. Wi-Fi, typically 20 meters inside. Outdoors, again, this is what I find. I have one of my routers right by my window pointing to my garage and my backyard, and I can be anywhere in my backyard and still be on Wi-Fi. I can be in my garage and be on Wi-Fi. So again, clear line of sight, you can go for normal there. So how about cellular towers there? How often do you see a cell tower? How far away? Do you see it? Do you pay attention to cell towers? There?
Yeah, when I lived in the country,
Yeah.
the cell tower was a mile away.
Oh.
Graveyard, people go climb it.
Right, yes. So it's always saying like 6 miles away or something like that. You can get again, there'll be just cell towers every so often. I drive to Grand Rapids, and so I know there's one outside Duluth, there's one in Floodwood, and there's one in Grand Rapids. So an hour and a half, about every 45 minutes of drive, there's a cell tower. But in between there, it drops and you won't get a connection. So like if you drive up the North Shore, there's one in Two Harbors, but it's between here and Two Harbors, it depends on which of your service providers. Each service provider has their own towers, and you might have different things. But I notice my cell signal drops out sometimes. But again, we can cover at least maybe 20 miles around one cell tower. In the city, we actually want to have 3 cell towers. In a perfect world, you're getting signals from 3 cell towers at once there, and triangulating them. But that's like Twin Cities life, not rural Duluth life here. So cellular is, again, now 5G has both a low speed and a high speed option. So if you've started doing more 5G, it's kind of confusing because the fast speed is actually you have to be relatively close to get the high speed option there. If you're further away, you'll get a low speed option for 5G. So even though it says 5G, it doesn't always mean it's fast. It depends how far away you are to the device here. So at least nowadays, we're kind of uniform with our cellular providers. It used to be the US had a different protocol than Europe or anywhere else in the world. So whenever you went outside the country, your phone wouldn't work.
Like fast or slow, or with the cell towers like transmitting, and like when things are fast or slow, you usually use like units to measure those things. So what are the units to measure?
Right.
All of that.
All of that.
Wi-Fi and the service.
Yeah. So let's talk about that. So there are. Let's move down to. So there's 2 terms, bandwidth and throughput, or through bandwidth. So bandwidth is the main thing. That's just your speed. Bits per second is usually what we are, or kilobits per second, megabits per second, something like that there. And you can run a speed test if you just type in test here into Google. You can bring up this speed test. There's lots of speed tests, but this is kind of a standard one there. And you can just run this speed test on any internet service. And again, depending on if you're on the internet, if you're on Wi-Fi or whatever, you can just run this and it'll try to download some data here, and then it'll try to upload some data and it'll tell you how fast it'll also tell you something called your ping, and we'll talk about that in just a sec. Okay, so download, this is megabits per second, 200, that's quite fast. And then upload is also very fast here, and that'll be, again, about 200 in both directions. So you can try that out here. Now, the other thing is, besides bandwidth, is latency. And there's an activity called ping, where you just try to send a message to another website and have it send a message back, just saying hi back. You ping them, poke them, whatever. Ping is the word we use, it's an acronym we use. And if you ping some thing, it'll tell you how quickly you can get a message back and forth to this. And this is what we call latency. We can't do pings on campus because our network blocks ping, because there's a lot of security issues with ping here. But again, ping is related to this latency, how long it takes to start up a connection or do a connection back and forth. Where latency comes in very important is when you're trying to send lots of messages back and forth, and timing is critical there. So like certainly if you've ever done online gaming there, that where you are trying to act and other people are trying to act at the same time, latency is critical for online gaming activities. You might have enough bandwidth to like send a file, but it will take a couple seconds for that file to start sending often. And where we see this is with like satellite. Has anyone had satellite internet there? So some of the satellite, older satellite like DirecTV on internet, they'd have a ping of like 700 milliseconds, half a second or more to start a message. And so that means like every time you want to do something, it's a half a second. So you really can't play a game or do an interaction with someone at that speeds there. Where other things are much like fiber or even cable TV are much faster. Now there's a new type of satellite called Starlink by SpaceX, and its satellites are very close. So where a traditional geosynchronous satellite is about 35 kilometers up, SpaceX has satellites that are about half a kilometer up here. So very close here. But I mean, not half a kilometer. That would be really scary. Rather than 35,000 kilometers, they're about 500 kilometers. For that here. So they're so close that we have much better latency with SpaceX, these low-level satellites that are out there. So yeah, bandwidth and latency are the two ways we generally measure that. So, okay, let's see. We could talk about what percent of the world is connected to the internet. So do you know anyone who's not using the internet there or doesn't have a computer? Yeah, or has limited, doesn't have a smartphone or something like that. So
Fully off grid.
yeah, fully off grid. Yeah, so there are people that choose them. There are people, I know a number of elderly people just never got around to doing the whole computer or phone sort of stuff. They still don't like it. Is that what you're thinking?
Yeah, yeah, I know,
Right.
they use 100 and,
Yeah,
no, that wouldn't fly for her.
right, yeah, so, it's interesting, and certainly, in some countries, internet is much more accessible than other countries, here. Also some technologies, as far as like cell phone technologies, are much more available in some places. We like to think that the US is at the lead of all the technology stuff, but if you start looking at internet connectivity and internet use, US is not in the lead in that sort of stuff there. So if you've ever been to places, Asia, Korea, Japan, or a lot of European places, their connectivity often is better than what we have here. So, I mean, you're just looking to, I mean, I don't know. In the city of Duluth, it's not bad, but if you get even 10 miles outside the city of Duluth, you do not have very many options. If you get outside where cable TV is, you just do not have, I mean, like Chris, he lives over by Esco and he struggled with internet there because again, it just doesn't have that many options. And we really saw that during the pandemic, where we also everyone wanted to Zoom for this. So, we have this client server model that we work with a lot. I think you're familiar with that. So we're often connecting up to a server here with this. In this nowadays talked about mainly in the term of cloud computing, that there are these servers in the cloud. There are these, in fact, there are data centers where they host these servers. There's a couple data centers in Duluth here that host servers that we have, but there's lots of others. So whenever you're doing something, you are generally connecting up to some server there. So like anytime you run one of your apps, you're connecting up, something that's getting data, like any of your social media apps, your YouTubes, your Instagrams, that sort of stuff, even Gmail, and going to any web page, all those are connecting up to some server to do it there. And any sort of game you're playing on your console or anything where you're connecting to another device or others and playing, again, you're connecting to this server sort of a relationship here. And again, a lot of times we're using this protocol, and we'll talk about these layers of protocols for this stuff. But let's just look at how HTTP works. So when we go to a web page, our web page will request a certain page, an HTML page here. That message is sent to our server or a server somewhere in the world. That server will then have that page and maybe any images that are stored on that page stored. It will then send that page back to our client, our browser, our computer, or our phone will display that page. It'll then request any of the images that it needs. And so sometimes on a slow internet, you'll see the page load and then you'll see the images load because, again, after we request the page, we'll go through that code, find any of these images and request those, and those will be sent to our phone also for this stuff. Now, there's actually a whole area below this because we generally type in www.host.edu or www.css.edu or my.css.edu, some URL like that. That has to be translated into a IP address with a number. So there's a whole underlying network called the domain name system that translates these names we use into actual IP numbers. And so that also is going on whenever we do something, whenever we connect to our page. So, okay, we talked about bandwidth, global bandwidth. again, different countries. Finland seems to be the fastest out there. Huh. Yes, right. So, yeah, I always am surprised how nice it is. Uh, at least now, when we go over to Europe, our phones work. I mean, 15 years ago or 10 years ago, we'd go over there and we are still using, what was it, GSM or something like that, some standard. So our phones wouldn't even work. I mean, you couldn't even swap SIMs out, because it was a whole different network over there. There you had to like get a different phone when you went over there. So it's at least now it's cell phone stuff. Everyone's using the same stuff. And even in the US now, you can swap SIMs a lot easier and swap providers much easier than you used to be able to. So, okay. And we talked about latency and pings. We're not going to do ping stuff. Okay. Okay, let's see what our reflections are here. So yeah, define what is bandwidth and what is latency here. So again, yeah, bandwidth is how fast we're sending data. Latency is how quick it takes the first packet to get there for that. So yeah, what's the difference between bandwidth globally as well as different locations of the US here. So it's interesting, yeah, you should try connecting different things. And not just internet, but you can also just talk about your cell phone stuff when you're driving around. Where do you see that here? There's been a lot of work on this digital divide here, and making things easier to access. Cell phone technologies has really helped in some developing countries. I know, 20 years ago, my sister spent a fair amount of time in Guatemala, and there was just one phone in a village. And so, like, when we would try to call her, we'd call there and talk to someone, and they'd say, "Okay, we'll go get her," and they'd hang up, and they'd go, down the block, find her, tell her there was a phone call. She'd come back, and she'd then call us back because there was this one phone in this remote village here. But 10 years ago, and certainly now, she was back there last year. But so even 10 years ago, 5 years ago, she was back there, and everyone had a cell phone, and there was a cell phone tower in this little village. And not everyone, but lots of people had cell phones and could text there. And that really helped a lot with that text messages. So, okay. So that's the digital divide. So we're going to do this activity. Let's see. So we're going to try to, again, we just, if you're trying to display a web page, how do you see this here? Let's see if these links. Yeah, so you can view these web pages here and try to go through this. So again, like I say, what we're sending is we have a server out there. We're a client that's connecting up to this server here. And then we're transmitting this web page around. You can actually see the protocol. If you click up in your web browser, the URL, you'll see it. It should say either HTTP or HTTPS. HTTPS is a secure encrypted version of HTTP. So almost everything nowadays uses HTTPS for a secure connection to your server for this. So if we're trying to display a web page like this, this is our web page, and we're going out to this server to connect to that web page for it. So again, this is what the HTML looks like here, and then you can see what it looks like for this. And again, here's another web page. And again, this is another web page on another server out there. So this just tries to show this diagram here. And again, this is the same one. Let me bring up this slide here. Here. So the user clicks on this web page, a link URL. We send the request to the server here, and that server on its local drive is storing that web page. It sends that HTML page back, and we display it on our page. We translate this HTML into something that looks nice on our page for this to do. You can actually look, at least in Chrome here, you can see what a page will look like here. Let's just say I go to css.edu here, I can go, there's some, under tools, there are called developer settings, and I can see the actual HTML that this web page is sending me here. So I can roll up and see the actual HTML page, because that page is coming to my web browser, and I can actually go, if I'm interested as a developer, and see what that page looks like here. So you can actually see that web page, this code, it just shows up differently, displayed differently on your page. So, okay, we're gonna do, let's see. I'm going to go on to the next chapter, I think, here, and try to do an activity with you on this network architecture. So, So we're going to try to explain how this internet works with this network architecture here, and what we call packet switching. So again, we have a network of networks here. So we have these routers out there, bigger, smaller ones, and each router is connected. So each one of these might be a router, and there's thousands of them connected, and they're actually connected in a hierarchy here, where some routers are connected to bigger routers and stuff like that. So for this. And again, every time we're sending a message, we are sending it from our host, like from your phone to your Wi-Fi router, from that router to other routers, and eventually to a server or something like that at the other end. So we have this connection through these routers there that we can get at. And again, we're going to skip some of this ping stuff because it doesn't work on campus, but we're going to talk about this packet switching. So one thing interesting with the internet is you're not guaranteed to that you're, what we do is when we send a message, like a web page or an image over the internet, we're going to cut it up into parts, send each part over the internet. So each part is a packet. We're going to send each packet over the internet. Those packets might take different paths over the internet. And at the other end, they'll be reassembled into the original image. So we'll take an image, break it up into packets, and these packets, and each packet, like packet 1 might take this path, packet 2 might take this path, packet 3 might take this path, and then we reassemble all the packets at the end. So how do we do that with our packets? here. And why do we do this? So this is packet switching. It makes for a very robust system that's not centralized. In a centralized system, if something goes out, your whole system will go out. This is our decentralized stuff. So we can lose certain segments of this internet and it'll still work here with this packet switching stuff. And again, I'm going to skip over this trace out. You can actually use tools that will tell you your routes here that are connected to the internet, and you can use things. But again, on campus here, some ping and sometimes trace routes are blocked here too. But here's where we're going to get. We're going to get to this TCP/IP model here, and we're going to do a simulation of this here. So if we're going to send a message here, well, let's just talk about what TCP/IP means here. So there's the physical connections to these different routers on the internet and our computers. And some of these connections might be Ethernet, some of them might be fiber optic, some of them might be Wi-Fi or cellular, but there are different connections, physical connections here. And then above these, we have this internet protocol, IP. And what that does is give every computer, every device on the internet is given an address, an IP address. So every spot, your phone, maybe even your smartphone, your computer that you're at, every device out there, your smart TV, all those things will have an IP address here. An internet protocol address there. And we can send, the IP protocol can send data from one IP address to another there. And what happens is that we send it to a router. The router will decipher it and look at the IP address and the IP packet and then know where to route that. So every router will have a routing table where, given an address, it'll have like maybe, well, this one might have 5 connections on it. Here, it'll know all those 5 connections, where to send every address or every range of address out there for this. That's the IP protocol. Above it is the transport protocol, and that will break a message down into packets and send the packets here. When a packet gets to the other side, this side will get that packet and send an acknowledgement back here. If the original site does not see the acknowledgement, it'll resend the packet here, and it'll keep resending it till it gets the acknowledgement back. What that does is make sure that even though these might be, part of these connections might be noisy, they might go in and out, someone might shut down a router temporarily or something like that, we might lose packets. The transport layer takes care of it. It makes sure that every packet is received at the other end and acknowledged. So the transport protocol is in charge of that. So above that, our applications, your, Instagram, your web browser, your games, all those things can just assume that they have a dependable connection that the transport layer provides here to work with. So we're going to try to simulate that. We're going to look at these 3 layers, application, transport, internet, and link layers, and try to see how we get information sent between these. I always think this is kind of similar to how the mail system works or stuff like that. So if someone wants to send you a package there, how do they send just an envelope, a message? You might write a message or send a package, and you might just leave it in your post box there, or leave it at the post office. And then you assume, in my mind, I just assume there is some mail carrier that takes that and runs all the way. So if I'm sending it to my daughter in the Twin Cities, I kind of imagine a mail carrier running down into Minneapolis and going to my daughter's door and putting it in her mailbox. But that's not how it works. There's not a mail carrier that runs from here down to my daughter's mailbox to deliver it. I don't know how the mailbox works, but I assume they put them in big bags, and the bags are sent down from our post office down to Minneapolis, and there's big sorting, and then it's sorted out and sent in, and eventually it's put on some truck for some person who drives each route, and that person will drive each route and know where. So there's a complicated system, but in my mind, I can put something in my mailbox and it magically shows up in my daughter's mailbox there. And similar here, your application assumes that it can just put something at the transport layer with an address, like an image. I'm going to send this image there, and that image will automatically get transported to your phone, and it'll be displayed just fine on your phone. And if you scroll up, we'll request another image, and that image will send that request back, and then that next image will be sent and transported here. So you don't need to know how this complicated system works when you're writing or working on these applications here. So again, we're going to look at this sort of stuff where, like, let's say we're sending an email here. There's a protocol called the Simple Mail Transport Protocol, where we're going to send a message. That message is going to be sent down to the Transportation Control Protocol, TCP/IP, where it's going to be broken into packets and transmitted. Each packet's going to be numbered. And at the other end, those packets are going to be acknowledged there. The IP protocol is going to route all these messages back and forth. Okay, so let's see if we can do this. How much time we have? We've got 15 minutes. Let's see if we can do this in 15 minutes. Okay, so we're going to try to send messages. I'll just warn you, this gets a little chaotic, but hopefully we can figure it out. So we're going to send messages from this side of the room to this side of the room. Okay, so you will get a message. And if you want, we'll see if we can get over, you can send a message back. Okay. So you're going to be the application layer. So you're going to send an email there. So you can just fill out an email message, a short message, and who it's going to be. Okay. Then we're going to need a TCP layer. So Chelsea, Connor, you're going to be TCP layers on this end. So you're going to, why don't you, you might have to scooch in the middle here. So you'll be, because we're kind of funneling this way. So you're going to need some TCP packets here. Right. Okay. And then next we need our IP layer. So there's now 4 of us in the middle here for IP layer. So you need to be an IP. You need to be IP. Okay, you're going to be IP. You're going to be, so on the other side, you're going to need some TCP packets. So, yeah. You're going to send some acknowledgements. Okay. Okay, yeah. Okay, you got some IP ones though? What? No, that's just what's cutting on. Okay, so let's see how we're doing here. Okay, if anyone, we have some writing, the community writing. Okay, so you are sending a message here, and you've got some email address here. So they filled out the application layer and they're sending a message here. And that's going to be sent to the transportation layer. So can you take your one transportation layer, you are another transportation layer. You are going to break this down into packets here. So you're going to send the packet here. So the URL, so I would say each of your TCP packets can contain, let's say, 2 words. So for your data, you can, don't do 4 words on the whole message, do 2 words. So you can do, so you're gonna have to send at least a couple packets there.
So we do sender being.
Sender being the address. Yeah, so you put the address down and you just fill out. So what that's gonna do is take that big, long email message that's 6 words long, and we're gonna break it up into 3 packets with 20 bytes each. Yeah, 2 words in each packet. There. And so we're gonna number each one of those packets there for things. So then IP people, you will take those packets and send them to someone else. We're not going to do routing, so just pretend you can look at the address and know where to go on it. But you're going to set whether you're going to assign each address. So let's assign each of you. So you'd be 143.110.01. You'd be 01. You're 02, 03. We are addresses. Okay. So you'll take this and you're gonna stick an IP packet around it or on top of it there like this. And put on, so you're gonna say where you want it to go there. So we're gonna need another. We're gonna, so I guess everyone will send it to Bluetooth. Right? Ian. Ian will be here and you'll be 143.110.03. And you'll send it to 03 and Ian will get all of those packets there. So you'll get those packets back. So yes, when you get a packet, you will give it to Ian. Okay. And so our IP is just in charge of routing things around. You can do multiple hops. So you will throw away the kind of cover message and just get the TCP packet, and then you'll give it to 03 and give it to Ian. So Ian, and you will give it, you will look at this and the recipient there. Oops. Sorry, and we wanted you to send it to one of those.
Oh, I didn't know their names.
Right. So, so we're gonna change it so maybe Alex. Axel. So change this from Mikhail to Axel. So
I guess it could apply even though he's wearing a hat.
yeah. So this is we're changing this to Axel. There. So. All right. So then you'll give it to Axel. Well, actually, we need the TCP people. Can we have you two come in here? So what we wanna do is wanna have application layer, TCP layer, IP layer, and another TCP layer over here. If you will come over here, and then this will be the application layer again on here. So we're all like right out here, so that, because Ian's gonna want to be able to hand you stuff, there.
I see why you think this is feel it.
Yes. Hopefully, at the end, it'll make sense. We've got 9 more minutes to make sense out of it.
Yeah, I did my part.
Yeah, okay, so you've got these messages, you're gonna take this TCP stuff, you're gonna throw away the IP stuff, and just take the TCP stuff and give it to the TCP layer, there, okay?
So if I have like a picture.
If it means anything, mine's first.
Yes.
Okay.
So you're gonna get those.
So I really went down now.
Now, you're gonna wanna make sure your message is all, you get all the messages, so there is 1 of 4. 4, so when you get this, you're gonna send the acknowledgement back. You received 1 of 4, and who's it came from, and who it's to, and we're gonna send that acknowledgement back.
You have what looks like a Y for one of them, and then what looks like a Q for another.
So, TCP people here,
Yeah.
you sent your messages, how many packets did you send? 4, you sent 4 packets to each, so you should be getting acknowledgements back from those. If you don't, you're gonna wanna send another copy of those packets. So you've gotta decide how long to wait before you send another acknowledgement.
We have people who are doing copies.
But,
We have people here who are doing copies.
yeah,
I think it's you guys doing the
Right.
copies.
No, I'm gonna be a very slow there. I will wait. I will sit there and wait.
I think she's gonna be the best.
No, I will gladly wait for it. I see people writing. I know I can think.
okay, so you got some, you got those, okay, we're gonna give each one of these, like this one. Okay, so you're gonna take that and you're gonna make an acknowledgement of that, you're gonna fill this
fine.
out. Okay, so you're gonna send, so you got this packet, 4 of 4, you're gonna write 4 of 4, and then who it was from.
There's a PCP layer working on it.
And then we're gonna send that back to that person, because they are patiently waiting for the acknowledgements. You are both patiently waiting for their acknowledgement.
There's like, with the application layer, there's a TCP layer, what's the next layer?
But there's a transport layer, T,
Oh.
transport TCP layer, and then there's the IP layer. Yeah, so TCP, IP, yeah, so there's TCP, and then there's IP in the lowest level,
Okay,
and then we go up to TCP again.
thank you.
Right. Now, one thing to consider as we're doing this is these messages go through a lot of different routers. Does anyone in the IP, you just sent text, did anyone in the IP, did any of you read the messages as they were running by?
Yeah.
But you could have. But you didn't, but that's not supposed to.
Cause you're.
Right. But as you're sending these messages, every router along the way could snoop and look at your messages along your way. So just keep that in mind. And that's why, like, we use HTTPS. Now, we're not doing that, where at this level, we would encrypt the messages. And then you would see an encrypted message there, but you would see where it's going from. So you'd say, oh, this person's sending a message to Amazon, and Amazon's replying back. So you could probably guess what they're doing there. Okay, and my top stuff for you guys. So we're sending these are going back to the IP layer, and you're sending them back to the TCP layer. So deliver them back over to this. Oh, yeah, well, we're not gonna do that. Yeah, but normally you put an IP packet around it. We're running out of time. So you would do this.
It's sent.
Now, why Why don't we have more IP back?
Yeah.
Here.
Thank you.
Oh, yeah, there are more in here, right?
This is my red receipt.
Yeah,
I have not read it yet.
Oh, dang.
so there's more of these, let me see, two or four stuff. Good.
Wow.
Oh, one part is another one.
Yeah, I tried.
Have a.
Now, as these messages are going far back and forth, you know, things can happen to our routers, little glitches and stuff like that. Strange things, cosmic waves can come in and actually disrupt the communications. Northern lights actually played havoc with this sort of stuff.
Really?
There, well, not the northern lights, but the stuff that caused the northern lights. Solar flares. And so the messages might not get there, or the acknowledgement not be back. So, but we know we have our very trustworthy TCP layers, and they will keep sending messages until they get an acknowledgement for everyone. And that's how we can guarantee that our messages will get over there. So you will get an acknowledgement back.
Wow. And
Okay.
so if you're sending a message way far away, does it have to repeat this process like a ton more times?
The TCP only runs at the two ends
Oh,
of things. So what? Let me go back here. So there'll be like, if let's say you're watching Instagram, so you're on Instagram and you are an Instagram server and you're looking at an image, you're saying, send me, your app is saying, send me this next image. You want to send that image back there. So that's the application layer. You have a TCP layer and they have a TCP layer there that breaks that image up into parts and gives each part a number. Each packet a number, send them, you're acknowledging that packet as you're getting it, your TCP people are, or, protocols doing that there. And in between is routing. So the IP stuff might be, this IP stuff might be going over Ethernet right here, and then fiber or satellite. But it doesn't have to get all the way up to the transport layer, just this internet protocol opposite along.
thank you.
Okay.
Thank you.
All right, we'll do more. You don't have to be doing the simulation anymore. Thank you for playing along. I appreciate it.
That was fun. We should
Yes.
start every class like
That's
that.
as much fun as we get. So see you on Wednesday. Yep.
Can you send me the recordings of the Wednesday and Friday?
I thought, thank you.
Yep.